Hello students, today we are going to start our new topic. uh, what are the factors on which the resistance of a conductor depends? So here are some factors. The first factor is what? Length. The resistance of a conductor is directly proportional to the length of the conductor. It means what? More will be the length of the conductor, more will be its resistance. More it can flow, more it can resist the flow of current passing through a conductor. The next is what? Area. The resistance of a conductor is inversely proportional to the area of cross section of the conductor. So more will be the area, less will be the resistance. In the combined format, we can write R proportional to L by A, that you can see in equation number 3. And we know that to remove a proportional sign, we need to give a constant. Here we have given a constant rho. R equals to rho into L by A. That rho is known as constant of proportion, that is resistivity. Here we will name the rho as resistivity or the specific resistance. From the question number 4 only, we can find that rho equals to R into A by L. So you can see over here that the formula of rho equals to R into A by L. From the formula only, by putting the unit of everything, we can find the unit of rho as ohm meter. But you can see in the formula that rho equals to R into A by L. That is, to find the resistivity or specific resistance, we need resistance, area and length. What does it mean? Does it mean that the resistivity or the specific resistance, that is rho, depends on area and length? No. It is a property of material of a body. It only depends on the material, what material we are using, and the temperature, nothing else. Next we are going to do some numericals. As you can see over here in the first numerical, the voltage of an electric bulb is given to 20 volt and resistance is 1200 ohm. Whatever numericals I have done, all the numericals I have done from NCERT examples, that is inside. So we need to find the current. According to Ohm's law, we have a formula that V equals to IR. So what will be I over here? I will be equals to V by R. By putting the value of V and R, we can find I is equals to what? 0.18 ampere. Similarly, for the same question only, there is one more part. Voltage remains same, that is 220 volt, but if the resistance is increasing, then what will be the value of current? So again we have the formula I equals to V by R. V remains 220 only, but the R comes here what? 100. So it will be what? 2.2 ampere. So voltage is same, but the current is different because of resistance. Next question is what? V equal to 60 volt, that is for potential is what? 60 volt, and what is the value of current? Current equals to 4 ampere. So to find the resistance, again we will use Ohm's law. V equals to IR, so R equal to what? R equals to V by I. By putting all these, we can find the value of resistance as 15 ohm. Okay, so we know now that resistance is 15 ohm, but the next part is what? Suppose we are increasing the voltage by double, that is the voltage comes now 120 volt. Earlier it was 60 volt, now it is coming 120 volt. Then what will be the value of current? So we know that I equals to what? V by R. By putting all this, we can find the current is what? 8 ampere. Next topic is for metal wire. Length is given of the wire, that is 1 meter. Resistance is given, temperature is given, diameter of the wire is given 0.3 millimeter. To find the rho, we know the formula of rho is what? A area into resistance by length. So resistance is given over here, length is given, but we have not been given the area. How to find the area? We know that the ends of the wire are in circular form, so we will find the area of the wire in as a form of circle. So equals to what? A equals to what? Pi r square. Diameter is given, from there we will find the radius. Okay, but it is in millimeter, we will convert it into meter, and then we will find the area. After putting all this, we will get the area, and once we get the area, then we will put the value of resistance, area and length in the formula, and we will find the value of rho. So our next topic is what? Resistance of system of charges. Or we are going to do what? We are going to combine resistance. Okay, Either we can combine the resistors in series form. Series form is what? If we connect the resistance end to end. As you can see over here in the diagram, R1, the end of R1 is connected with R2, the end of R2 is connected with R3. This is known as series combination, end to end. Okay, you can see in the diagram, there's a voltmeter V, there's an ammeter A. As we know that the work of ammeter is to find current, measure current, and the work of voltmeter is to measure voltage, potential difference. Okay, you can see our key also over there. It is a key. Okay, this is a complete circuit. In series combination, what happens? In series combination, the current through all the resistors will remain same. As you can see over here, I have divided that the potential of the first is V1, the potential of second is V2, the potential of third is V3, but I have not done anything for the current because it is series combination. In series combination, the current will remain same for all the resistors, whereas in the parallel combination that we will do later, in that the potential difference remains same but the current varies for all the resistors. So first we will do it for the series combination. In the series combination, as you can see that the potential difference of all the resistors are different, that is V1, V2 and V3, but overall what is the potential difference? That is V only, that you can see over here, it is V only. Now current remains same through all the resistors, and the total potential difference through all the resistors, that is V1, V2 and V3, will give, as if we do the total of that, we'll get the total potential difference B across all over the circuit. Okay, so we can use over here that V equals to V1 plus V2 plus V3. According to Ohm's law, what we know, that V equals to IR. Okay, as you can see over here, I have written over here IRS. IRS I have written because we are using series combination, so RS will give here the value of series resistance. V1 equals to what? IR1, V2 equals to IR2 and V3 equals to IR3. Now we'll put the value of all these in the equation. V equal to V1 plus V2 plus V3, and after putting all this value, what you can see over here, that I is common in all the components in the right hand side, so we can take I common from there. So what we are getting, RS equals to R1 plus R2 plus R3. What is the result of this? The result is this: if there are number of resistors and they are connected in series combination, and suppose if there's a question to find the equivalent resistance, then what you are going to do, you are going to simply add all the resistors, then you will get the value of equivalent resistance. This is for series combination. Now we are coming for our next part, that is parallel combination. As you can see over here, that I discussed earlier, in the parallel combination the current will be different for all the resistors, but the potential will remain same. You can see there is only one V, that is potential is same for all the resistors. Why potential is same for all the resistors? Because the ends are fixed. You can see there are only 2 points, and all the resistors are fixed between these 2 points only. And I1, I2 and I3 are the value of current across all the resistors. So their current was same for all the resistors. Here potential difference is same for all the resistors. In the series combination, the total potential difference was equal to the sum of all the potential difference across all the resistors. Here the total current, that is capital I, which is going through the resistor, you can see over here, this one will be equal to the sum of all the currents through all the resistor. So there we got V equals to V1 plus V2 plus V3. Here we are getting what? I equals to I1 plus I2 plus I3. Now what we will do? We will apply Ohm's law. We know that V equals to IR. So I will be equal to what? I will be equals to V by R. There we use the term RS because it was series combination. Here we will use what? RP because it is parallel combination. So I equals to V by R. At the place of I we will write V by RP because it is total one. I1 is what? V by R1, I2 V by R2 and I3 V by R3. Now you can see in the right hand side that all the components have common V, so V will take common and we'll get what? 1 by Rp equals to 1 by R1 plus 1 by R2 plus 1 by R3. So if you have been given a number of resistors which is connected in parallel, then how you are going to find the equivalent resistance? You are going to find the equivalent resistance by adding the reciprocal of all the resistors, and at last you will reciprocate it again to find the resistance of parallel combination. Okay, now we are going for our next topic, that is heating effect of electric current. This is a very important topic. What is the topic I will tell you? Suppose I think all of you have electric iron in your home. Okay, we use electric iron for our clothes also. So what is heating effect of electric current? Whenever the current passes through a conductor, any conductor, the conductor gets heated. This is known as what? Heating effect of electric current. So what is the theory? That whenever the current will pass through any conductor, it is a wire, metal, anything, the device or the conductor will get heated because of flow of current. Okay, because it energizes the particles of the conductor which comes in random motion. Okay, because of that only energy increases, it gives heating effect of electric current. So the heat produced over here depends on three things. As you can see over here, the heat is directly proportional to the square of current. More the current, more will be the heat. The heat is directly proportional to the resistance, and the heat is directly proportional to small t. That small t is what? The time of flow of current. Suppose a same current is flowing through a conductor once for 2 minutes and then again for 4 minutes, in which case there will be more heat in the second case, because here the time is more. In the combined form, if we will write over here what? H proportional to I square RT. Suppose here the constant is what? 1. So it will be H equals to I square RT. Okay, this is known as Joule's law of heating. Now that I square R, we can break it in IR into I into T, then also the value will remain same. But why we are breaking it over here? IR, again we know that IR equals to what? V, according to Ohm's law, V equals to IR. Okay, then we will replace IR by V, so it will be what? VIT. So we have two formulas now over here, H equals to I square RT and H equals to what? VIT. This is known as Joule's law of heating. What is the practical application? It is it has both effect, undesirable and desirable both. It is undesirable as it converts useful electrical energy into heat energy. Sometimes after a long run, when you will touch your fan, ceiling fan or any fan, you will feel that it gets warm, because that electrical energy is getting converted into what? Heat energy, because of heating effect of electric current. So here what it is a demerit for us, because our useful energy, which is electrical energy, is getting into converted into heat energy, which is not useful for us. Okay, the unavoidable heating can increase the temperature of the components also and alter their properties also. What are useful applications? Electric oven, we know that electric oven is there, electric toaster is there, electric heater is there, electric bulb to produce light. These are what? These are heating effect of electric current. Electric heater also you have at your home. With what principle you are using for electric heater? That is only heating effect of electric current. Electric fuse is also an example of heating effect. We use fuse in our home for the safety purpose. That also depends on electric heating effect of electric current. We will study in detail about the electric fuse later.